So hello, a very good evening to all. So in this video, we are going to see the solution of our 11th IIT AIT 2 पेपर राइट. सो आज हम लोग देखेंगे किन किन क्वेश्चंस में तुम लोगों ने प्रॉब्लम को फेस किया है राइट. सो वी आर ट्राइंग टू सॉल्व दोस क्वेश्चन एज वेल. द ओवरऑल द पेपर वाज वेरी इजी एंड कंटेन अ वेरी गुड कॉन्सेप्ट क्वेश्चंस राइट. सो अगर तुम लोगों ने अच्छे से इसको पेपर को सॉल्व किया होगा देन क्लियरली यू नो दैट कि बहुत अच्छा पेपर था, कॉन्सेप्ट्स क्लियर होंगे और किसी भी क्वेश्चन में जिसमें कोई प्रॉब्लम है. So we are going to see the solution in the today class, right? So let's start with the today class. Okay, the first question. So this question is from the limiting reagent, right? So what the question asks basically? So in this question, the question is given like 10 gram of hydrogen and the 64 gram of oxygen were allowed to react in the vessel. You have to calculate the amount of water produced in this reaction, right? So you have to calculate the amount of water produced in this reaction. So this question is from the limiting reactant. So first of all, while solving question related to limiting reagent, you need to write the chemical equation involved in this equation, right? So basically hydrogen and oxygen, right? That is 2 mole of hydrogen and 1 mole of O2. This will react together to give 2 mole of H2. So this is the balanced chemical equation. So from the graph, we can, from the equation, we can clearly observe that that is the 2 mole of hydrogen required for the complete reaction of the 1 mole of O2 to form 2 mole of H2. So now quickly convert all this thing into mole. So here 10 gram of hydrogen. So 10 gram of hydrogen means what beta? That is hydrogen having molecular mass 2. So that is 10 by 2. So this is equal to 5 mole, right? This is equal to 5 mole. Similarly, for the oxygen, this is 64 and O2 having molecular mass 32. So on solving, you'll get this is 2 mole, right? So 2 mole of O2 and the 5 mole of H2 hydrogen is given according to the question. So what is the amount of water produced? First of all, you need to calculate the limiting reactant. So how will you calculate the limiting reactant, beta? How will you calculate the limiting reactant? We know that 2 mole of H2 that is 2. देखो बहुत सारे तरीके लिमिटिंग इथेनॉल कैलकुलेट करने को सोशियोमेट्री डिवाइड करके भी कैलकुलेट कर सकते हैं. बट इन दिस वीडियो आई एम गोइंग टू प्रोवाइड यू द theoretical concept about how to find the limiting region. That is basically 2 mole of H2 require 1 mole of O2, 1 mole of O2 for the reaction, right? So 2 mole of H2 require 1 mole of O2. So according to the question, 5 mole of H2 is given. So 5 mole of H2 require how much? So 5 mole of H2 require 1 by 2 into 5. That is 5 by 2 mole. 5 by 2 mole of O2. 5 by 2 mole of O2 means what beta? That is 2.5 mole, right? But in this question, only 2 mole of O2 are given. So we can say that the required amount of O2 is 2.5, but in question, there is only 2 mole of O2 is given. So obviously, O2 is our limiting reagent. So oxygen is our limiting reactant, or we see limiting reagent. Okay, so this is how will you calculate the limiting reactant. Now, once you calculate limiting reactant, then you can easily find out the amount of water form, because the amount of product form is totally depend upon the limiting reagent only, right? So here we can say that that is 1 mole of O2 gives 2 mole of H2. So how much many mole of that is 2 mole. So 2 mole will give us 4 mole of H2, right? That is 4 mole of H2. What is the correct answer? That is the 4 mole. So this is the correct answer for this question, right? Sure. Let's move to the next question. That is question number 32. So consider the reaction 2A plus B. This will give us, this is 2A plus 3B, and this will give us C. Initially, there were 2 mole of reactant A, 2 mole of reactant A, and 3 mole of reactant B. Then which of the following statement is true? Right. A is the limiting reagent and will get consumed first. So it will say that basically 2 mole of reactant A is there and the 3 mole of reactant B is there. Right. So both having the same number of mole. Both having the same number of mole. That is, actually they require 2 moles of reactant A and 3 moles of reactant B, and in the given equation also the 2 mole of A and 3 mole of B is given. So both the reactant A and B will get consumed at the same time. So this is the correct answer, right? Because both having the same number of mole, 2 ratio 3. So both will consume at the same time. So this is very, very simple question. Now move to the next question, that is question number 33. So consider the mixture of hydrogen and oxygen where the mole fraction of hydrogen is 0.5. So in this mixture, what is the ratio of masses of hydrogen and oxygen? So you have to calculate the ratio of the masses of hydrogen and oxygen, right? So how will you calculate, beta? So considering a mixture of hydrogen and oxygen, and the mole fraction of hydrogen is also given 0.5. So let me calculate first the ratio of the number of mole of hydrogen to the number of mole of O2. And this value comes out to be 1 ratio 1. That is 1 by 1. Right. Now, this we can write this mole as, how will you write the mole? So we can write number of mole as, that is mole is nothing but what? That is mass upon molecular mass. That is mass divided by molecular mass, right? So this mole is equal to mass divided by the molecular mass. So how will you write this equation? Yes, we can obviously write this equation because their ratio is what? Their ratio comes out to be 1 by 1. Suppose this formula is for hydrogen. So similar for the oxygen, we can write as mass of oxygen divided by molar mass. So this is for O2 and this is for hydrogen, right? It rather we can write as like this is. So now what is the ratio of this? So we know that their ratio is comes out to be 1. So this is 1 ratio 1. Just multiply, that is weight of H2 divided by the molecular mass of H2. Similarly, weight of O2 divided by the molecular mass of O2. So on putting the value, because we know that weight of H2 and what is the molecular mass of H2, that is 2, weight of O2 and what is the molecular mass, that is 32, and this is already equal to 1. So from here we can calculate the ratio of weight of H2 upon weight of O2, which is comes out to be 1 by 16. So this is the ratio of the weight of the hydrogen. Okay, ratio of the masses of hydrogen and the oxygen, that is 1 ratio 16. So which option is correct, beta? That is option number C. So option number C is absolutely correct for this question. Okay? Chalo. Now move to the question number 34. So which of the following can never represent an empirical formula for the compound consisting A and B? So you have to identify. So it is very easy to, we can easily say that, that is E, because empirical formula, the ratio of the number of atom in the molecule has to be simple whole number. Right. And 2 by 8 is not a simple ratio and can be reduced to 1 by 4. Right. So this cannot be a simple ratio because we know that 2 by 8 further reduced to 1 by 4. So empirical formula must consist of the simpler ratio, which is not possible in option D. That's why option D is the incorrect. Now, move to the question number 35. क्या कह रहा है भाई 35 question? So, how many grams of oxygen is required to burn 4 gram of methane gas completely? Right. So, this is also a very, very, very important question. So, let me write the equation for the combustion, that is CH4 react with O2. So, they will form CO2 plus H2. So, let me balance this equation, right? So CH4 plus 2O2 gives the CO2 plus 2H2. So we can say that 1 mole of methane, in this question they're asking how many gram of oxygen is required to burn 4 gram of methane, right? 4 gram of methane. How many oxygen is required? So we can clearly say that that is 2 mole, 2 mole of O2 is required to completely burn 1 mole of methane. 1 mole of methane. Right. In gram also we can convert, that is 2 into 2, 32, that is 64 gram. So 64 gram को burn करने के लिए methane we have methane for example 12, 16, right? So that is 16 gram. 16 gram of methane. So 16 gram of methane require 64 gram of O2, right? So 4 gram required, 4 gram required is equal to 64, 16 into 4. So कितना आ गया ये? Yes, in solving you'll get 16 gram itself. So which option is correct, beta? That is option number E. That is 16 gram. ठीक है? चलो. Now move to the next question. That is question number 36. So which of the following pair of gases contain the same number of molecules? So you have to identify which of the following pair of gases contain the same number of molecule. For example, we have the 16 gram of O2 and 14 gram of N2. So this is the again question from the mole concept, right? So if you look at the option A, then we know that 16 gram of O2, right? Because 32 gram, that is the molecular mass of O2, is equal to Avogadro number. We all know that a molecular mass is also equal to the Avogadro number, that is number of atoms present in a one mole. And similarly, for 16 gram, for the 16 gram of O2, the value is Na by 2. Hmm? Similarly, in case of N2, that is 28 gram produce Na. So 14 gram present Na by 2. So in this only, that is option number A, this is correct, right? That is this pair contains the same number of molecules. Chicken. Now move to the question number 37. What is question number 37 basically? So according to question number 37, the molecule present in 5.6 liter of SO2 at HTP is 1 mole and SO2 present in 22.4 liter. So the molecule present in 5.6 liter of SO2 at HTP is given and you have to calculate the molecule present at 5.6 liter of SO2. ठीक है? 1 mole of SO2 present is already know that is 22.4 liter. ठीक है? So we all know this thing. This is a very simple mole concept question. We know that 22.4 liter of SO2 contains, ठीक है? 22.4 liter of SO2 contains how many molecules? Yes, that is 6.023 into 10 raised to the power 23 molecules. ठीक है that is 22.4 liter of SO2 contains 6.023 into 10 to the power 23 molecule. So we know how will you calculate 5.6 liter. So 5.6 liter contain divided by 22.4 multiplied by 5.6. So on solving what you'll get 1.5 into 10 to the power 23. So which option is correct, beta? Yes, that is option number E. Is absolutely correct, right? That is 1.5 into this. ठीक है चलो. So question number 38 from the structure of atom, that is quantum numbers. So which one of the following sets of quantum number are not possible? So we all know that and if n is equal to 2, L is always n minus 1. So L never become equal to n. So in option number B, you can observe that n is equal to 2, L is equal to 2, which is not possible. So that's why option B is not permissible. ठीक है चलो. Now, move to the next question, that is question number 39. So, how will you calculate the number of the radial node? So, we know the formula for calculating the number of radial node. So, okay, for formula for calculating the normal radial node is equal to n minus L minus 1. So, this is how you can actually calculate this. So, here n is equal to 4 and L is equal to 1 for P and 1. So, this is 4 minus 2, that is 2. So which option is correct, beta? That is option number B. So always remember the formula for calculating the radial node. Then we can calculate radial node by using the formula that is n minus L minus 1. Chalo. Now move to the question number 40. We have in this question there is the two statement is given. Two statements already provided in this question. You have to identify this statement. So statement 1: the radius of the second orbit of helium is equal to that of the first orbit of hydrogen, and the radius of an orbit of hydrogen like species is directly proportional to the n square and inversely proportional to the z. So is this true? Is this true? Yes, we know that for calculating radius the formula is 53 into n square upon z, right? N square upon z if you want to calculate it picometer. So we can say that the radius of an orbit of hydrogen like species is directly proportional to the n square and inversely proportional to the z. So statement 1, 2 is absolutely correct. But what about statement 1? the radius of the second orbit of helium is equal to that of the first orbit of hydrogen. This won't possible, right? This won't be possible. तो ये नहीं हो सकता possible. That's why we can say that that is statement D. Option D is absolutely correct. Right. How will you find the radius of the second orbit? For example, if you want to calculate the radius of the second orbit of helium, hmm, helium plus and second orbit होना चाहिए इसका. So this is 53 and the second orbit means you are using n that is equal to 4. And what is Z here? In case of helium, the atomic number is 2. So this is 53 into 2, that is 16 picometer. Okay? Now, similarly, if you want to calculate the first orbit of hydrogen, so the first orbit of hydrogen, so for the first orbit of hydrogen, we have 53 into 1 ka square upon 1. So this is 53 picometer. Right. So this is 106 picometer and this is 53 picometer. So we can clearly see this. This won't be equal, right? That's why statement 1 is incorrect. So what is the correct answer for this question? That is option number D. Now, move to the next question. That is question number 41. So basically in copper plus, the number of cell occupied, subcell used orbital, and unpaired electron respectively. So copper, the number of cell occupied, you need to calculate subcell and used orbital and unpaired electron. Copper plus. So we know that copper having electronic configuration 3d10 and 4s1. So copper plus having electronic configuration 3d10. Okay. So they have a zero unpaired number of electrons. So no unpaired electron is present because we all know that D subcell having 5 orbital 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have no unpaired electrons. So number of unpaired electrons is equal to 0. So either option C or option B is correct. Huh? Eliminate option number D and option number A. Now the second is use orbital. And so what is the number of used orbital? So used orbital we are using here, that is 3D. So the number of orbital that we are using in this question, this question is number of orbital, that is 0 and this is 14. Right, this is 14. How? You can actually calculate, right? The total number of shell occupied कितना हो जाएगा? 3D. कौन सा शेल में है? 3. थर्ड सेल में 3D आ रहा है ना? तो 3 शेल में. सब सेल कौन है भाई? तो D है. तो नंबर ऑफ सब सेल ऑक्यूपाइड कितने हैं? 6 सब सेल को ऑक्यूपाइड कर रखा है. ठीक है. तो दैट इज 6 सब सेल को ऑक्यूपाइड कर रखा है. एंड द नंबर ऑफ ऑर्बिटल फील्ड कितने हैं? दैट इज 14. सो और नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन दैट इज 0. So which option is correct? That is option P is absolutely correct for this question. Now move to the next question. That is question number 42. So the state is all. This is also a statement with question. The statement that is not correct about the periodic classification element is right. The first option is the properties of the element are the periodic function of their atomic number. No metallic elements are less than their metallic counterparts. In transition elements, the 3D orbitals are filled with the electron after the 3p and before 4s. And the first answer enthalpy generally increase with increase in the atomic number as we go along the period. So out of this, which option is not correct, right? So if you considering option number C, in case of transition element, the 3D orbital are filled with the electron after the 3p and before 4s. No. So they are filled after 4s, right? After 4s, we filled 3D. So this statement is absolutely incorrect. Okay? Chalo. Move to the next question number 43. That is the period number of in the long form of the periodic table is equal to. So period number in the long form of periodic table is always equal to the principal quantum number, right? Because if I'm talking about the second period, it means all having n is equal to 2. If I'm talking about the third period, all having n is equal to 3. So always remember this thing, maximum principal quantum number of the element in that period is equal to period. Okay? Chalo. Now move to the question number 44. So this question is also very easy question. That is in the question number 44. An atom with the high electron activity has. So जो atom जिसका electron activity high होगा. So they also having the high ionization potential. Yes. Low ionization no. ये तो metal हो गया. And large sizes, no. Low electron affinity, no. So which option is correct? That is high ionization potential. Okay? Chalo. An element with atomic number 29. We all know this. This belongs to the D block, copper. So they are talking about the copper. So they belong to the D block element. Now, four elements P, Q, R, and S have the atomic number Z minus 1, Z, Z plus 1, Z plus 2 respectively. Of Z is 17. Then bond between which pair of element will be least covalent? ठीक है बताना है किसके बीच least covalent होगा. So Z is equal to 17. If the Z is equal to 17, so what is P? So P is equal to Z minus 1. That is 16. Hmm? And q is equal to what? Q is equal to z, that is 17. And r, that is r is equal to z plus 1, that is 18. And s is equal to 17 plus 2, that is 19. Now you have to identify which pair of the element are least covalent. Least covalent means more ionic, you can also say. So which of the following is the least covalent? So if you considering the example of ionic, that is NaCl. So for the ionic bond, the size of the cation and anion of should be the same of, right? Because if the cation size is smaller and the anion size is bigger, then the covalent bond will be formed, right? So here we can observe that in which case this possibility is there. That is the least covalent, means ionic bond, right? So basically in S and Q, we can say that S and Q, because S having 19 and Q having 17. So here we can say that, right? So S and Q. So these are the least covalent, right? These are the least covalent. Now, select the correct statement out of the following. That is question number 47. So, both lattice energy and the hydration enthalpy decrease with the ionic size. Lattice energy can be calculated using the Born-Haber cycle. If the anion is large, so I guess all the 3 points are very much correct. So, the correct option for this question is all of them are correct, right? So, these all are the basic definition of the Born-Haber cycle and the lattice enthalpy. Okay? Chalo. Move to the question number 48. So a formal charge of nitrogen in NO and NO2. So you have to calculate the formal charge in NO and NO2. So let me draw the structure of NO. So the structure of NO is like N double bond O, E, and N having 5 electrons, out of 2 electrons are in bond formation and these 3 electrons are there. Similarly, if I'm talking about the oxygen having 6 to 2 and 2 lone pair they are having, right? So this is the structure of the NO. So how will you calculate the formal charge, beta? So formal charge we can calculate, that is the formal charge in, if you want to calculate the formal charge of N in NO, right? Of N in NO. So how will you calculate, beta? You can calculate it, that is the valence electron, that is equal to 5 minus number of lone, sorry यहाँ पे एक है, that is number of lone pair they having 3 plus number of bond, that is 2. So this is equal to 0. Now similarly, if you want to calculate for the NO2, so how will you draw the structure of NO2? The structure of NO2 is like this is NO and this having some dative bond. So yeah, this is the structure of the NO2. So if you want to calculate for the NO2, we can say valence electron remains same, that is 5, minus lone pair remain 1 electron only. Huh? And this will they will form 3 bonds. So this is equal to 1. So 0, comma 1. So which option is correct, beta? That is A. 48 का कौन सा option correct है? A. That is option A is absolutely correct. Now move to the next question. That is question number 49. ठीक है? Question number 49. In which of the following molecules or ion all the bonds are not identical? So they are asking in which of the following all the bonds are not identical. So basically, if you want to consider this thing, all bonds are not identical, right? So in case of XZF4, if I'm talking about the BF4, right? So they are XZF4 having the square planar, right? This type of shape they having. So all they having the equal number of lengths, right? XZF4, so they have the same. BF4 again, CIF4 is again a tetrahedral. So these all are supposed to be same. Now, if we considering the structure of C2H4, how will you draw the structure? C, and here we have H, 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 and H. So we can say that in C2H4, all bonds are not CH bond, right? There is also some carbon-carbon double bond. So we can say that in this the bond is not equal. So which of the option is correct, beta? That is C2H4. Okay. Now move to the question number 50. That is which of the following facts regarding the I3 ion is incorrect. So you have to identify the incorrect statement regarding this. So let me draw the structure of I3 negative. So how will you draw the structure of I3 negative, beta? The structure of I3 negative, like this is I and this is again. Hmm? So they having 7 valence electrons. So they will single bond with this. They also having 2 to 4 and to 6 and possess some negative charge and make bond with this. That is 2 to 4 and to 6. Right. So which option is incorrect? So if you try to read the option, that is there are two I atom around the central I atom occupy the equatorial position. So there are the two I atoms around the central atom. So because B option, if you considering the option B for the central iodine atom, there are two I bond pair of electrons and three lone pair of electrons that need to be distributed in the trigonal bipyramidal shape. Right here. So we can say that the option number D, that is there are two I atom around the central atom, is incorrect option. Okay? So this is absolutely incorrect question for this. Question number 51 is very common question and they are generally coming in many exams, right? So this is a very simple question, that is क्वेश्चन नंबर 51, राइट. तो आई होप सबने ही इसको अच्छे से किया होगा. बहुत सिंपल क्वेश्चन है, आसानी से कर सकते हो. तो क्या है क्वेश्चन में, देखो जरा एक बार फटाफट. So they are asking a gas is found to have the formula COX and their vapor density is 70. So you know the relationship between the vapor density and the molecular mass, right? So what is the relation is this, beta? That is vapor density. That is a we can also write as molecular weight is equal to twice into vapor density. Hmm? So we can calculate this, that is 2 and the vapor density is 70. So molecular mass comes out to be 1/4. Okay. Now what is X? X is equal to mass upon molecular mass. So just put the value. So what is mass molecular weight? So this is the let me write again. We calculate the molecular mass here, right? That is comes out to be 140. Now, we know that we know that mole is equal to chicken. We know that the mole is equal to, because in this question they're asking COX. What is this X? So this X is nothing but is equal to molecular weight divided by weight of CO. So molecular weight we calculated 140 and this is 12 plus 16. So on solving you will get around 5. Right. So which option is correct? That is 5. Oh, sorry. This is the numerical type of question. So we can write as 5. So 5 is the absolutely correct. Okay. समझ आया? Right. So let's see the solution for the next question. That is question number 52. So what is asked in this question? So in this question, 1 mole of the potassium chlorate is thermally decomposed and excess of aluminum is born in the gaseous product. So how many mole of aluminum oxide, that is Al2O3, are formed? Right. So first of all, let me write the equation for this question, right? So that only you can able to solve. So 1 mole of potassium chlorate, right? So this is the potassium chlorate, that is KClO3. So when this react, they will give what? They will give KCl plus O2, right? So let me balance this equation. So for balance the equation, this will become 2 KCl. This is also 2 KCl. This is 3 O2, right? And excess of aluminum is bond in the gaseous product. So यहाँ पे gaseous product क्या है? O2 है. Right. So this react with 4 aluminum. This react with the 3 mole of O2 and they will give 2 mole of Al2O3. Right. Good. So the molar ratio of the first reaction is 2:3. Right. Here the molar ratio, that is 2:3. Right. 2:3. And simply KClO3 and O2. Right. This is the KClO3 and O2. Thus, if 1 mole of KClO3 is decomposed, obviously, if the 2 mole of KClO3 is decomposed, we get the 3 mole of O2. So, if the 1 mole, according to the question, if the 1 mole of KClO3 decomposed will give 3 by 2, that is 1 by 5 mole of O2. Mole of O2. Right, यहाँ तक clear है? Okay. Now in the second step, the molar ratio for O2 and L2O3 is, so we can say that 4Al and this will produce 2Al2O3. Clear hai? So the molar ratio for the second reaction is nothing but the 3:2. If you're considering oxygen and aluminum O2 3 only, na, so the ratio become 3:2. So the 3 mole of oxygen produce 2 mole of aluminum oxide. Hmm? Since we have only 1.5 mole of oxygen, so the number of mole of Al2O produced, because 3 mole of oxygen will produce 2 mole of Al2O3. So we have only 1.5 mole of O2. So 1.5 mole of O2 will produce how many? That is obviously 1. Because if the 3 mole produce 2 mole of Al2O3, then 1.5 mole will produce 1 mole only. So what is the correct answer for this question? That is 1. So yeah, that is 1. So this is very interesting and very good question, right? Now move to the next question, that is question number 53. So in this you have to calculate the energy of the photon, right? So we can easily calculate the energy of the photon by using the formula like Hc upon lambda. So H here already given H in this question 6.63 10 raised to the power minus 33. So 6.63, this is 10 raised to the power minus 33. C we have 3 into 10 to the power 8, and lambda we also have lambda we have to calculate. Energy is already given, right? So energy is given and lambda we need to calculate. What is the energy given? That's 3.309, 3.309, 3.309 into 10 to the power minus 19. So this is very simple question, right? 3.30 into 10 raised to the power 19. So you just by putting the values, you can actually calculate lambda for this question, right? So this is very simple question. I hope all of you easily do this question, right? So what is the correct answer? On solving, you'll get the correct answer. So what is the correct answer for this question, beta? That is 656, right? That is 656 meter. Okay, so 656 meter is the correct answer, lambda. Now, move to the question number 54. That is the wave number of the first line of the Balmer series of the hydrogen atom is given, that is 15,200 centimeter inverse. What is the wave number of the first line of the Balmer series of lithium plus iron? Right, so you need to calculate the wave number of the first line of the Balmer series of lithium ion. So let's see how will you solve this question number 54, right? तो कैसे होगा ये 54 क्वेश्चन, चलो देखते हैं फटाफट. So we all know that is wave number is equal to 1 upon wavelength is equal to RH into Z square, and this is nothing but 1 upon N1 square minus 1 upon N2 square, right? So this is what we need to calculate. Okay, so wave number is equal to 1 upon lambda RH into Z square, 1 upon N1 square minus 1 upon me N2 square. Okay, now for first line, for the first line of Balmer series, for the first line of Balmer series, what is N1? So for this N1 is equal to 2 and N2 is equal to 3. This is what we have. This is what we have. N1 is equal to 2, N2 is equal to 3. So we can just put the value for the hydrogen. So wave number is equal to 1 upon my wavelength of hydrogen is equal to RH into just multiply by 1 because we calculated for hydrogen. And this is 2 square minus 3 square. Okay. Similarly, for the lithium ion, this will become plus 2, 1 upon lithium plus 2. This is RH and atomic number of lithium is 3. And this is 1 upon 2 squared minus 1 upon 3. Right. So on solving, you can actually calculate the value of B lithium plus 2. Hmm? So this value comes out to be on from this two equation only, that is 1 and 2. So on comparing, you get the value of this. So this will comes out to be 9 into wavelength of H, which is already given. That is 9 into 1500, 200. This is already given, 15,200. So on solving, you'll get 136800 centimeter. So this is the correct answer for this question. ठीक है, चलो move to the question number 55. That is the number of possible orbital all types in n is equal to 3 energy level. So n is equal to 3 energy level में कितना possible है? So if let me calculate, if n is equal to 3, we know that L is equal to what? L is equal to 0, 1 and 2. Hmm? That is L is equal to 0, 1, 2. So for L is equal to 0, we have S subcell. S. L is equal to 1, we have a P subcell. L is equal to 2, we have a D subcell. Okay? So for the 3s orbital, for the L is equal to 1, we have a 3p. So we can write as this is we have a 3px, 3py, 3pz. Here we have only 3s. And here we have 3dxy, 3dxyyz, 3dzx, 3x square y square, and last is 3dz square. So we have 5. So 5, 3, 8 and 1. That is 9. So total is equal to 9. So the correct answer for this question is 9. Right. So 55, the correct answer is 9. So let's move to the next question. That is question number 56. So number of angular node for the dyx atomic orbital. So you have to calculate the number of angular node for this. So we know the formula for the radial node, that is n minus L minus 1. Similarly for the this one, that is equal to angular node. So you want to calculate the angular node, right? So what is the formula for calculating the angular node, beta? So for calculating the angular node, we have the formula like for D. So this is D, right? So only the formula is angular node is equal to L, right? And for the D, L is equal to what? That is 2. L is equal to 2, right? For D orbital. So the correct answer is 2, right? So 2 is the correct answer. Okay, now move to the question number 57. That is the sum of the bond order of the oxygen species. So we already know this thing. We have a trick to calculate the bond order, right? Here we have a electron sum. Here we have bond order. So if the electron sum is 10, 11, 12, 13, 14, 15, 16, 17, 18. Corresponding order we have 1, 1.5, 2, 2.5, 3, 2.5, 2, 1.5, and 1. Right. So here in case of O2, the electron sum is O2 16, 15. So corresponding to 15, we have from this table we can have 2.5. Okay. Now O2 negative. So 16 and 17. For 17, we have 1.5. So corresponding to 17, we have 1.5. Now O2 twice negative, 18. So for O2 twice negative 18, we have 1. And O2 16. That is for 16, we have 2. So just calculate this. 2.5, 0.53, 4, 4, 5, 5 to 7. So the correct answer is 7. Right. So what is the correct answer for this question? That is 7. Okay. Now move to the next question. That is question number 58. So how will you solve this question? Question number 58. Okay. चलो फटाफट देखते हैं. The total number of bond in C2 twice negative in a CaC2. So let me draw the structure of CaC2, right? Then only you are able to solve this. So we know that C2 twice negative. We can draw the structure like C triple bond C and this whole twice negative, right? So it can be thought of as the C2H2 without the 2H atom. We can also consider as C2H2 and 2 hydrogen atom is removed so that we have a 2 negative charge on them. So C2H2 without 2H atom. Hence 2 pi and 1 sigma bond is there. So there is the 2 pi bond plus 1 sigma bond. So total number of bond is 3. right? So this question they need to total number of bonds. So total number of bond is equal to 3. Now move to the next question, that is question number 59. Write the Lewis dot formula for the CO2 and calculate how many sum of the lone pair electron and pi electron are there. Right. So let me draw the structure of CO2. So for drawing the structure of CO2, this is a very simple linear structure of CO2. Right. So we have this structure of the CO2. So how will you calculate the value? Right. So in this question, they're asking, write the Lewis dot formula of the CO2 and calculate how may sum of lone pair electron and the pi electron. So you have to lone pair of electron and pi pair of electron. So we have 2 to 4 to a 2 electrons there, 4 to 6 and to 8. Right. So total number of electron we have. Let me calculate again the value. Like this is oxygen. Hmm, and this is carbon, this is oxygen, this is 2, this is 2, this is 2, this is 2. So total number. So here we have 4 because in one bond 2 electrons are there, so 4 electrons there, 4 electrons there. So total we have 8 electrons. 8 to 10, 10 to 12, 12 to 14, 14 to 16. So total number of electron is 16. ठीक है? चल. Okay, move to the question number 60. Right, this is the last question. That is, write the Lewis dot formula and the death formula of the SO4 twice ion and calculate how many a lone pair of electron. How many lone pair of electrons? Okay, not me. How many lone pair of electrons are there? So let me draw the structure of H2SO4. SO4 only, SO4 twice negative. So the structure of SO4 twice negative is SO, O, O and O. Twice negative means two oxygen having the negative charge, right? So two having formed by the this dative bond and this one. Okay. So they having twice negative charge. Quickly write all the lone pair of electron. Here also they have 6 electron. Hmm? Now, so we can write as this is 6 electron and here they have two, four, two, six and 2 to 4 to 6 to 8 electron. Again here also 2, oh, so sorry, 2 to 4 to 6 and to 8. So if you want to calculate this, so total number of what you need to calculate how many lone pair of electrons. So the lone pair of electron is how many lone pair of electron. So total we have one lone pair, two, three, four lone pair here, four lone pair here. So four, how many? That is 8 and two lone pair here, two lone pair here. So total we have 10 lone pair of electron, right? So total we have the 10 lone pair of electron in this. समझ आया सबको? Because in this question, they have write the Lewis dot formula and the dash formula for sulfate ion and calculate how many lone pair of electrons. So you need to calculate the lone pair of electron for this, right? So how many lone pair of electrons are there in this question? Okay. So how will you calculate the number of lone pair? We can actually calculate the lone pair by using this. Right. So let me draw again. If you have any doubt related to this SO4, that is SO4 twice negative ion. So this is the structure of SO4 twice negative ion. Right. Two oxygen having the negative charge, so they have the 6 lone pair of electron. So just calculate this. Here we have the 2 lone pair of electron. Here also we have a 2 lone. Total 2 4, and here is this we have a 1 2 3. So 4 and 3 7, and here 3. So total number 10 number of lone pair we have. Right. सो वी ऑलरेडी डिस्कस ऑल द क्वेश्चन सब क्वेश्चन हम लोगों ने डिस्कस किया बहुत इजी पेपर था तुम सब लोगों ने बहुत अच्छे से इसको किया भी होगा राइट सो this is all in today class so let's meet in the next class where we're all discussing about the some more important topics right take care and just read